Okay, there we go. So that never happened. Great. Okay, so today we are going to be doing again a little bit of a quick review for C++ for 135, and then we are going to jump into talking at least about vectors and maybe a little bit about classes. Okay, this is the first official video since the previous one was about the syllabus. I see that some of you have questions on the assignment, so I will try to cover some of the things that might be useful to know for the assignment. But yeah, as for the difficulty of the course, since there was some things about that, yes, that is going to. I mean, okay, let's be realistic here. About 50% of you will fail the course if you're not careful, because that's what the pass rate tends to be at. So yeah, so you know, don't be that 50%. So I will do my best, but I'm just being realistic with you. It's like, you know, if this is how your degree goes, this is 135, this is 202, and then this is like 302 right there. Okay, so and then the parallel to this 218 is just hard in general too. So yeah, it's pretty serious stuff. So don't feel bad if you're struggling. Everybody struggles. The question is whether you fight through the struggle and still make it. Okay? And we do have the pass-fail rate kind of back, in that if you get a C, that's the same thing as an A if you apply for the pass, because you don't see the GPA affected. But if you get a C minus or less, then that is not passing, and you can switch it to a fail, so it doesn't affect your GPA. But still, so yeah. That's just the statistics. 50% of people get less than a C. That's what I consider a fail, by the way. I'm not saying like F, but C minus might as well be an F, because you still got to repeat the course. So yeah, and that is not just my section, by the way. That is overall all the sections of 202, and I believe the retention rate is something like 22%, or graduation rate is like 28%. So that's like a quarter of the people that are left at the end of the degree. So hey, if you graduate, you get paid a lot of money though. So there's that much. Okay? So not to demoralize everybody, but more to like make you all be aware that you are gonna have to put in a lot of time to this course, especially if you struggle through 135. It's not just gonna magically get easier. So if you breeze through 135, that's good. That means you have that momentum going for you. But if you struggle with 135, then unless something happened over the summer, then you're still gonna struggle. So you just gotta work it together, okay? And take advantage of your TA for that as well. Okay, so is there anything in particular that you would like me to review, other than me just like flat out just trying to review random things like what a for statement is and whatnot? You can feel free to post it on the chat or yell it out loud, but I am recording, so your voice will be recorded. Vectors, okay, vectors. Let me make a list here. Vectors, file streams, arrays. That's kind of in the vector category, but okay. Vectors, arrays. Okay, all right. Let's just do that then. They're all basically the same thing. So let's start out with vectors. So I don't know how many of you have used vectors, but if you haven't, no fear. Vectors are not something that is extremely hard to do. Structs, okay. So let us talk about what an array is and then build to the vector from there, okay? So when you're trying to store data in a computer, you know, if you declare independent variables like A or B, you know, this is cool and all. In fact, you could do some really weird naming convention. Like you could say, well, I'm gonna make A1, A2, and A3 like that. And yeah, I mean, that'll work, but it gets to a point when you should stop doing it and realize that it's not fun trying to like update all these variables at once. You just have insane amounts of code. Somebody posted on Discord some years ago some meme about some game where like somebody did this in an actual game and the game was like really inefficient or something. Yeah, refer to Discord for that. I don't remember what the name was, but it was some anime thing probably. That's everything on Discord appears to be. So yeah. something simulator. I don't know what it is. It's not XXX simulator. That sounds weird. No, I don't know what it is though, but yeah. Okay. So anyways, the idea of an array is that you can store a homogeneous group of information. Homogeneous means that it's the same type. So all integers, all floats, all doubles. By the way, it doesn't have to be. You can use pointers, which we'll learn later in the semester, and like store different objects. In fact, you can use reinterpretcast and store like anything you want in there. Not a good thing to do, but I'm saying it's possible. The idea of when you really want to use arrays is when you just have a bunch of data of the same type. So a list of numbers, and they're all integers, okay? And so you want to store like a one-dimensional table, basically, of that, okay? So you have like 1, 2, 3, 4, 5, 6 numbers in there, okay? And so the way you declare, that's it, the Yandere simulator. Yes, that was it. Yes. So yeah, you know, they posted a video of that and how it's coded with things like that. So yeah, Google that, I guess. Okay. Content warning. I don't know if it's for kids, but yeah. Okay. So basically, if you want to declare an array, what you do is you put the data type, and then you put an identifier. What are the rules for identifiers? A through Z, uppercase or lowercase, doesn't matter. Numbers 0 through 9. But you can't start the identifier with a number. You can also use an underscore as well for that, but I don't recommend you do that. However, it's okay to use them in the middle. So if you have a variable name that's called like car speed, I guess that could work. But you can also use camel case like that. Doesn't matter. But anyways, you can, and then numbers again can be anywhere, like at the beginning, not everything but the beginning. So do not do this. That will not compile. Okay. So anyway, so type identifier. So let's say we're going to use A, and then the square brackets. That indicates that it's an array. However, you want to put in there how big of an array you want to use. So if you want to make an array to fit this data, which is 6 numbers, then you're going to put a 6 in there. Okay? So let's just jump in and code this stuff. It's better that way, because if I make mistakes, then we will detect them. Okay. So let's just get rid of that. Yeah, we can leave that function in there for now. We might use that. Okay. So let's just make sure that this is running. We break it, we might have broke this. Semicolon. Okay. Where's my output? Here, it helps if you put an end line to see it. It's at the beginning, but yeah. There you go. Okay? So you can see that. Okay, cool. So, if I would like to store an array in here, I declare it like this, and then if I would like to access its members, I can use a loop, such as a for loop, and then iterate through each of the indices of that array. Obviously, right now, they are supposed to be random, although the debugger is probably going to set them to something, if I was to guess. Oh, no, cool. They actually are random. Beautiful. So as you can see, they're uninitialized, right? If you would like to initialize them, then you can do that in another for loop. Actually, you could initialize them like this, too. I think this will work, although you really rarely use this. 2, 4, 6, 8, 9. Okay. Oh, I guess we missed one. Do we not have 10? 2, 4, 6, 8, 10. Oh, ooh. Okay, no, never mind. I thought for a second we were doing something very bad. but no, we are going from index 0 to 9. So, oh, this is why. Okay. We're actually printing out the address of the array at the end. That's what this address is, which should change actually every time we run it. But it's not. That's probably because of the debugger. It's always assigning the same one. But yeah, we can comment that out. Okay. So there we go. Okay. So I mean, yeah, that's basically how arrays work. I don't know if I can go more in depth to that right now without spending a lot of time, but I mean, is there any particular part of the array that you would like me to review that you're rusty about? I mean, really, it's all about declaring your array with a fixed size and then accessing it by using the index. And then remember, the arrays start from 0 in C++. So if this array is 10, the indices go from 0 to 9. And that's how you get the 10 indices. Okay? So just make sure you all don't be doing weird things in C++. This is not Fortran or other languages that start from 1 or something. I think Fortran starts from 1. I'm not 100% sure. It might be Pascal. One of those two does. MATLAB starts from 1, and it's just like scary. Like I've coded in MATLAB. It is not fun. Oh, 2D arrays. Okay. 2D arrays. You can just do that, and then bam, you're good to go. So this becomes now a 2-dimensional array. Let's actually make it much smaller though. And then if you want to access that within a for loop, so that you can initialize it or modify it, you got to do a nested for loop. Normally you would put the J on the outside, but since I already coded it, then we're going to do that. Sorry, I'm trying to type tilted to the left. Move the keyboard a little bit. J is less than, okay, so it's a 3. We're going to use the inner one like that. And then J++, and we're going to change this one to be 5. And then semicolon, because we're not in Python. And then here, we're going to make this I, we're going to make this J. So here's the tricky part when you're having to do this mess with nested for loops. First of all, don't do what I did. Actually use curly braces because it helps to avoid confusions. What I had it would have worked because of the way the compiler interprets this code. It'll actually think it's nested. But if you had one more line of code inside of the for loop, then it wouldn't work. So just play it safe and throw in your curly braces throughout just to be safe. Okay. So next is you got to make sure that, when you're iterating this dimension, it is actually up to this size. So that's why the J is 3 and this one is 5. Okay. If you flip these things, the program is either going to crash or give you garbage data. One of the two, which neither one is good. Okay. Oh, I mean, actually right now it'll give you garbage data anyways. I wonder if this still works. I think this will actually initialize everything to 0, but I don't know. Maybe I'm thinking of something else. We'll see if that compiles. Oh, it did compile. Perfect. That's one way you can initialize everything in an array. You just put it there. So yeah, we got a bunch of zeros here, although that's not very exciting. So what I'm going to do is I'm going to copy and paste this loop above it. And I'm just going to insert some numbers in there. The way that I access that is by using the assignment operator like this. And then we're just going to insert a random number that is a combination of the addition of the two indices. Oh man, the semicolon stuff sucks. I missed Python already. Okay, so let's count these. We got 0, 1, 2, 3, 4 repeated. How many times? It should be in theory 5 times. Oh, no, that's because of the count. That's weird. That's weird how that math is going on. Okay, let us make my life easier with the math, and let's just make a count variable, assign it to 0, and then just increase it here. Let's start it with 1, like that. Actually, you can use auto for this and it would work. I think it would work. Auto picks the variable type for you based on what you're assigning it. It's a nice little shortcut. Just if you're like me and you want to just use Python and C++. So, yep, it is indeed. So anyways, we can see that there are 15 of these, which does work because that's 3 times 15. So yeah, it's all coded and working correctly. And you do the same thing for 3-dimensional arrays. We'll play with those more later on, but at least for the assignment, I don't think you got to go beyond 2 dimensions. So why didn't they say this in 135? Because they don't want to confuse you. Like when you're first learning to code, you want to make sure you understand the different variable types. So like if you just put auto there and you don't understand that this is a float versus like an integer, like, well, actually in this case it's an integer, by the way. I'm just saying in the case that it was like a float, then people get confused. Like if you wanted to make this a float, by the way, if you did this, then this is actually going to be a double. You'd have to put an F in front of it and now it becomes a float. So this is the kind of trivial things that you might not know when you're first starting to code. So it's good to actually be, what do you call it? Specific, like, not specific, just to be thorough that you're explaining what your code does, you know. But yes, type inference, yes, that's a good keyword. I like that. Type inference. That's how it makes you sound smart. So it's good to use those keywords. Okay, so yeah, let's move on to vectors now, since we don't have that much time to review, you know. But I do have videos for 135 material, and there's again tons of resources online, including Geeks for Geeks. In fact, for vectors, I actually assumed that you guys would ask about vectors, and I found the link ahead of time. So that is going to be your Geeks for Geeks link for vectors, and it has tons of examples on that, like tons. Very good stuff. So arrays are cool, but the thing about arrays is that you have to specify the size when you're creating the array. In fact, actually, the code will compile if you don't specify the size. It'll give you a warning saying that it's like not a good thing to do, but it'll compile and it'll run. It's just not doing actual like static arrays. It's actually doing like dynamic arrays. We will learn how to dynamically allocate memory in like 3 weeks, no, like 5 weeks. But we're not there yet, right? So one quick and easy way to have the power of dynamic allocation without having to learn it yet is to use vectors. And I encourage you to use vectors in the first assignment because like I don't even know if that thing will crash on CodeGrade. I haven't heard anything from it crashing from the instructor that helped me to implement the solution in CodeGrade, but it might crash on your computer if you use the 50,000 size for assignment 1. So vectors are your friends. They handle things way better than this. So normally what I do is I save the code so that I can share it with you in the future. I do want to use this one because I haven't set it up for the debugger. So maybe what I'll do is I will copy and paste it into a folder called notes, and we'll just label it by number. So this will be like 1. Because what I'll do then is I will, like, at the end of the week, I will upload these for you, so you have them, samples, code snippets every day. Okay? So we'll just do it like that. That'll work. That way I can still use the same one that's like set up with the debugger. By the way, let's test if the debugger's still running. Yeah, it's still running. So you can see that. Let's look at the variable watch. Look at that, updating. Can you see that actually? Yeah, you can see it on the edge there. So yeah, okay, perfect. It's good to see the debugger. Could you show a quick example of max elements too, maybe if you have time? What do you mean by max elements? Is that like a vector thing, or are you talking about the assignment? You have to kind of be more detailed about that because I have no clue what you mean by that. But yeah, while you tell us what that means, let us go ahead and delete this and go ahead and throw in some vector magic. Should just leave that in there. So for vectors, you have to include the vector class, vector library. I don't know if class is the right word for that, but it is a class actually. But yeah, you do that by saying include vector. And so now, if you want to declare a vector, it's a little bit like declaring an array. The syntax right now is going to look weird to you, but this is from the Geeks for Geeks, the vector int like that. But when we talk about templates, you'll understand why this is the syntax that is used. Okay. Vector thing. Okay. Yeah, I'll look at it here then. I'll find out. I probably check the size of it, but or actually, it's the maximum allowed size to allocate or something. But yeah, so what this does is it creates a one-dimensional quote-unquote array. And so this thing will grow on demand. And that's the beauty of it. Like an array is fixed size. So like you make an array of size 10 and it's always going to be size 10. If you need something of size 11, you have to make a new one. You have to copy all the members manually, deep copy, which we'll talk about later on, and then you can't delete the other one because it's already defined. So like you've already wasted that space anyway. So it's kind of sucks in that sense. With dynamic stuff, you can, if it's an array, you still got to copy things over, but at least you can delete the older one, or you can use some pointer magic to just kind of keep appending to it. So that's the beauty of these vectors here. That it's very easy to grow in size, and you can insert things on demand. So like you don't need to define something bigger than what you need, and you never have to worry about the size. So if you coded enough C++, and you probably have in 135 with arrays, you know that's a really nice thing. Okay, it's like not something to be taken for granted. Okay, so how do we do this? How do we insert things into there? Well, there is a pushback function for that. And that is basically what you're going to do. So like if we want to insert 5 in there, we do b pushback, and that will throw into the vector of 5. This is your member access operator. You've seen that when you were working with the string class in 135 and probably when you were doing structs. So we will talk more about that when we get to classes again. But for now, just remember that's the syntax. B is going to be the name of whatever you put in here. So if this was an A, then this literally becomes an A. And then here, what you put inside the parentheses, so it's like a function. What you put in there, it's not like, it is a function. What you put in there is what's going to be inserted. You got to make sure that that is the same type as whatever is here, okay? If you don't do that, this thing will either try to coerce the value into the type that it is. So like if you put in here like well, actually I don't know. I don't even, this might get casted, like coerced into like a 5, or it might just give you an error. Let's see what happens. Did it run? Question mark. Show errors. Oh, well, hold on. Semicolon. I'm so missing spacing so much here. So let's oh, cool. We got the variable watch. Beautiful. This will be cool here. Let us run this code manually and see what happens here. So when this line of code runs, if we look in A, we can see that A had a 5 stored in it, even though you fed it a 5.1. That's because it did that coercion, or I don't want to say casting. I don't know if coercion is the right term either, but it did that. It changed the type of the class, or the type of the value, sorry. So it went from being a double, this is a double because there's no F in front of it, to being a integer, okay? And we're, hopefully today I get to talk about what function overloading is in the first place, because that's one of the things I have listed here to teach. But yeah, so that's the only thing you gotta be aware of when you're dealing with the vector, that it's going to try to do this. If it succeeds, it'll do it. If it doesn't, it won't compile, but or give you an error. But be aware of that. Like I don't know how to emphasize this, but like you can lose data this way. Like if you're meaning to store the actual double value and it's storing an integer, and this is like literally code that's like computing a math formula for like a rocket ship, then your math's going to be off and the thing is going to crash or not pop its parachute or like not get to space, right? And you think this is a joke, but like this actually happened. There was a ship that was coming that was landing in Mars, and there was some of the code was written in feet, and the other part of the code was written in metric system, and imperial versus metric. And there was a part of the code where the numbers got mixed up, and so because of that, the altitude reading was off, and the parachute I don't think opened, or the heat shield didn't pop out. Something happened, and the thing crashed into the planet. I think that's the way that went. You can Google that, like coding error, NASA, and yeah, that happened. And that was millions of dollars lost. So you are not in that situation because that's why you're in school, because you can screw that up here instead of screwing up when you're working for NASA. So very important, okay? Very important. Don't screw up your types. Don't mix types. Be very clean about that. Okay, that's how you put in things in the vector. Let's put in a couple of other numbers in there, just so that we can trying to delete the 5, but I forgot to keep the shortcuts for that. Shake my head. Okay. Let's put this at 2, 1. Okay, so let's go ahead and first show you how to print contents from the vector. Do you have time for vector of a struct? I mean, I don't know. I think, you know what? Maybe we do that when we go over like classes. Because when we do classes, then I can show you how to put that in a vector. Because I don't know. I mean, it's as easy as like putting the type of class here. So instead of putting this, like you put A if your class is A. And then you push in the objects. So it's not super hard, but I'll show you examples eventually of that. Okay? So how do you do a for loop? Well, for the for loop, I believe that there is a size function in the vector class. So you could do something like for int I equals 0, I is less than a dot size, maybe. And then I plus plus. But I'm going to show you a much cooler way of doing this in a minute. And then if you want to access the members of the vector, you can do it just like if it was an array. So use the same format. In fact, if you compare the code with the one we just wrote earlier, this loop looks the same, except I don't have to keep the size variable separate. I can just, it's just part of the class, which is pretty nice too. Makes the code easier to read and work with. But let's see if it works. Run code, please. Okay, as you can see, or can you see it is a question. Let me move it up a little bit actually. There we go. As you can see here, we got our values there, okay? So this is cool, but there's a better way, especially if you're like me, like you like Python, okay? And that's using range-based for loops. Make sure it works before I tell you it works. Okay, it worked. So yeah, bam, done, easy. So if you all know Python or you heard of Python, it's a cool language, better than C++ for coding things quickly, but maybe not good when it comes to efficiency and space and time and whatnot. So this is known as a range-based for loop, and at least for me, I learned it first in Python, and then I found out C++ had it. And what you're doing is these vector objects have an iterator that can basically go through each of the individual elements. And so the syntax looks a little weird because of this colon, but let me kind of explain what is happening here. It's a for loop still, and what you're doing is you pass in your vector on the right side, and what you want is you want it to loop through each element of the vector. And so this I value is going to be a temporary value that is going to take a copy, or I don't know if it's a copy or a reference. I believe it's a copy, but it might be passing by reference. I'm not 100% sure. I think if you want to pass it by reference, you got to put an ampersand in front of it or after it. We'll play around with that later. But basically, what you're doing is if it's a copy, you just take a copy of an element, which is why you see out like this. The reason I use int auto here is because the vector already has a type defined to it, so it'll auto fill it in. So in this case, though, int has one less letter, so maybe I should have done int. But I just wanted to show you the use of auto again, since some of you haven't seen it before. So very cool, very easy, much cleaner than that nastiness, right? Let's see what we have. So if you have a struct name, struct name, do you have a vector struct name? Yeah, so if you have a struct like that, then your vector would be like this. And then trying to insert things into it would be something like this. So a temp dot x gets 5, and then you would do something like, well, I haven't shown you how to do pushback yet, but you would do something like blah dot, oh wait, no, I did show you, right? Yeah, I did show you pushback. My bad. And so then you just do pushback of temp like that. And then just to show you that this works, then you use the for loop for auto I and blah. you do C out. Let's just say we're C outing the X. So you're going to do I dot X. And then semicolon, run that code. God, what did I mess up? For auto I blah, oh, C out. Oh, semicolon. Don't forget your semicolon after your structs. What else is wrong? Vector int A. Semicolon there. Really? Return 0? Is that why you're complaining? Curly brackets. Where are the curly brackets that I'm messing up? For the loop I made. No, the loop is fine. Loop don't need it. That's fine. Yeah, it's just a single line, so... Oh, I know what it is. Oh, wait, no, it's not that. I was thinking it was a variable naming convention. Do you identify the others in the struct? Actually, let's just see what the compiler says. Return statement with no value. It's really just complaining about that. Maybe, let's just run it again. Yeah, okay, that's weird. It was complaining that main did not have a return value. That's not really a big deal, but okay, why not? Okay, yeah. So, anyways, basically, this is like the 5-second version of what you need. So yeah, so you make your struct. Whatever you put here is what you're putting here. This is just whatever, and then for now, because you don't know any way better, you have to manually make the object first, fill in all its values and fields. And then when you're ready to insert it into the array or the vector, you do the pushback, and then you put the name of the object here. Okay? When we learn about constructors, all of this code will be simplified. Like I said, you already know everything you need in 135. We're just learning ways of making this code nicer. And this is one example of that. The pushback function is literally the way to insert things into your vector. So like when you say pushback something, it's just throwing something into your vector. So like whereas the array, you have to put an index and insert it that way. This is more of like an insertion, like you just have like insert it. And it is always going to insert it to the back. Okay, that's important. Something good to emphasize. When you do pushback, you're putting things in the back of the array. Okay, so it's always going to the back. There are ways to insert in the middle. There are other functions for that. Check out that Geeks for Geeks link. I believe it's called insert, and then you put the index where you want to insert. Yeah, insert. So you can do that as well, but you probably won't need any of that. The other one that's useful to know is going to be your pop back. So let me just get rid of this, and let me comment out this. You can leave the rest of the code there. So yeah, we're back to this. Okay, so let us say that we would like to delete things from this array. Let's delete that last 5. What you do, and let's do that before we print it, is we do a.popback without any parameter inside of the commenter. God, semicolon. Okay? And as you can see now, the 5 is gone. So now we got 521, whereas before we had 5215. Case in point. Okay? So pop back allows you to remove the last element. So pushback inserts, pop back removes. If you want to access it, you can just do it with the index like you would with an array. This is just a list append method in Python, right? Yeah, exactly. Yeah. So if you know Python, yes, append is literally the same thing as pushback. So when you're making a list in Python, you see you're talking my language now. Yeah. Then yeah, so you use append. Okay. So very good, very good. So as you can see, this is much nicer than working with an array. So there's like literally no reason why you'd ever want to use an array over this, like honestly. But the powers that be said you learn arrays in 135, so you learn arrays in 135, right? So yeah. Okay. So what else was there? Let me see. Vectors. Oh, file streams. Oh, file streams. Okay. Yeah, file streams. I've literally not used a file stream in 8 months, so let's see how this goes. Okay, let's just put that at the bottom here, okay? I remember when I first learned vectors, I hated them and loved arrays. Yeah, we all have these things where we like something until we like learned that we were wrong and we should have done something else. It's part of the learning process. Not to feel bad. F open. think. And then like a file name. So do we have a file here? Oh, let's just open ourselves. Very bad thing to do, but why not? And then let's assign this. I think we need to do like fstream or ifstream. Fn. And then fn gets fopen. Is that it? ifsteam. Stream. Okay. And then open, and then like let's just see if this runs. Semicolon. Oh, really? That was like complaining for a real reason. No, it doesn't like it. Hold on, let me just open the reference. Geeks for Geeks fstream. Ah, yeah, okay, you're right. That makes more sense now. Yeah, but then it's open. It's not just, yeah, okay. Yeah, that looks more legitimate. Although it is not liking it. Let's just see if it really doesn't come out. That's weird. See, there's something going on with this with the IntelliSense, because like, see, it had that underlined, but it was okay. So I had to recompile it to get rid of that error. So it's just being glitchy. But yeah, okay. So yeah, so if you want to open a file, you use ifstream. If you want to write a file, you use ofstream. So like this is where you want to write to something. And so if you want to write to something, then it's the same thing, but in this case, it's going to be the output file. There are parameters you can put here to specify whether you're reading in and out. They're probably here on Geeks for Geeks. Yeah, you can look at that. But anyways, for now, we'll just open it, like just open basically kind of thing. Is there any reason not to use fstreams instead for both opening and writing? You're free to use whatever you want, basically. So, yeah. If you have a different way of opening it, that's fine. Like I said, I just kind of use whatever comes to my mind at the time when I'm doing an assignment or something. So, yeah. But anyways, after you open it, you basically, if you were to do something with cout, like cout hello world, then if you just want to change that to write to a file instead, you just change it to whatever the variable name is. So like fout. I like fout because it literally is like cout with one character difference, right? So you can do something like that. And then, yeah, that should work as long as I have a semicolon. And then for the fn, the same thing. So if you want to read in, let's create a string variable. And let's read into that string variable. And so what is it going to read in there? Let's just read it outside afterwards. But it's probably going to be the word include IOStream. There we go, include IOStream. See that? Because we're opening our own file, which is really bad thing. Because like that's, I had a scenario where like I had a student who was using file streams and like they screwed up the name of the file. They put main.cpp and then they just literally overwrote their entire assignment by writing over, like, you know, when they I think it was. Yeah, I think that's how it worked. That's what they did. And I was like, well, you know, sad, but at least they did it like on day one. You know, they had just started coding it. So it wasn't like they did it last day. That would have sucked. Make backups of your assignments. No. Just don't make the backups public. Otherwise, people will copy from them. Like, don't put them on GitHub as a public repo. So, yeah. Let's go see if the other file was written too, though. Which one are we running here? Test folder. Okay. Here we go. Hello world. See that? So we created the file. One other important thing that you should probably do is close the file after you finish working with it. So you do that by saying .close. So fin.close. I wonder if there's a way like in Python where like they have the with open thing. There we go. So, yep, that's all there's to that. Okay, so last, I already showed you a struct. So this is the syntax of a struct because people were asking about that. You write the word struct, you put an identifier, you put a curly bracket, you put another curly brace, and then you put a semicolon, and in between you put your member variables, which could be other structs even in there, but you have to define those structs above it. But it could be variables, whatever you want, float, arrays, although that's kind of scary. Beware about that, and so on. Okay, so that's it. That's all the time I have for the review, because I want to start teaching you actual useful tool 2 stuff. Okay, so hopefully that was useful. But again, I have videos of 135 online, and you can watch those. You can also go and check it for Geeks, or you can go to the TA who is nice enough to help you out, especially as you're working on the first assignment, which is meant to trigger your memory from 135, and if not, to tell you what you need to practice or what you need to learn still. So somebody had a question about a max element with the vectors. Let me see what that is about. Let me see. Max. So there's max size, but I don't know about elements. Yeah, you must have been referring to the max size. The max size is like some limit of the number of things that it can hold, but you don't have to worry about that. That is all handled by the computer. As long as you keep pushing back, it'll work. As long as you have space in your RAM, which you will. At least for this class. You're not doing like some massive thing that requires like 100 gigs of RAM or something. So, yeah. Okay. Let's just take all of this and save it again to the folder. Oh, no, not folder. File. Okay, so now, oh, darn it. Okay, so based on what I said we would talk about, well, actually that's all I have listed, but I didn't list function overloading, which is something that I do want to talk about. It's just one of those things that they don't, I mean, like, how many of you know about what function overloading is? Or how many do not? Because I don't think that's something that's consistently taught in 135. So it's a good starting point for School 2 to teach that. I will take your silence as acceptance of not knowing it. Okay, there we go. Okay, perfect. Good. That's fine. That is why I'm going to cover it today in the next half an hour. And then if we get through that, we're in good shape. So let me explain to you, and this is also a good review of functions as well. So it's a double edge, two rocks with one stone, two birds with one stone. If I have a function called foo with one parameter, we're going to call that parameter int a, and I call foo from main with a 10, and maybe the function goes ahead and see out int foo, and then also throws in the value. Okay, that's all the function does. So if I go ahead and call that function like this, and maybe I call it twice, I call it with a 22, actually let's call it 3 times, and with a 22.5. Okay? Run the code with F5, and this is what we get. Int foo 10, int foo 22, int foo 22. We know why the first two happened, because it's an integer. The third one is the same thing that we were talking about with the pushback, where it's doing that coercion or casting from 22.5, and it's taking that double value and cutting it up into a integer, right? Isn't it a function copy but with separate parameters? Yes, that is kind of what I'm going to get to. So yes, you have the right idea. Okay, so Cool. Okay. So now suppose that I wanted to do the same function. We're going to call it bar. But this one, we wanted to take a double. Okay? So it's the same function, it's going to do the same job, but it's going to take a double. So it's going to say double here, double foo, and it's also going to print out a value. Okay? So now we're going to have the same function. And we're going to call the same values, but with the bar function. Okay, so we still got the same one from before, but now in this one, when it comes to the third value, we get that 22.5 correctly. Very cool. Okay, now, what if I would like, because like when you do, if you know C, you have the print function, but in C++ you don't really have that, but like you might have used some functions in 135 that were like math based. Or like absolute value or something, where like it will take any value that you feed it to, or like to upper or to lower, or any function that you've used. It's flexible. It takes different types of numbers, whether it's an integer, a float, a double, it doesn't matter. It'll take them, and they'll work just fine. So, how do they achieve that power? Well, they still use the same function name, but they have different parameter types. So if I go in here and I change this to a foo, and now let's get rid of all of the bars. We don't need this anymore. Let's see what happens. So now, this doesn't exist anymore. Actually, sorry, what am I saying? The bar function doesn't exist anymore, but we have two foo functions. They both have the same function name, but they both have one parameter as well. But the parameter is a different type. We have an integer type and we have a double type. And as you can see, all three calls are to the foo function. However, the first two calls are going into the top one, to the int foo. The third call is going into this one. Why is that? Because the parameter type of the first two is an integer. 10 and 22 are integers. But 22.5 is not an integer. It's a double. And it's going there. Cool. So that's basically what function overloading is, as an introduction. You have the ability to overload a function, which means you can make it do more than one thing. You can have multiple definitions of the same function as long as they have a different number of parameters, or if they have the same number of parameters, that they have different types of parameters. What do I mean by different number of parameters? Well, I could write another foo function here. I'm going to compress them by putting them like this, just so we don't, because we don't have a lot of space because of the font size. Okay? So we're going to say void foo int A, int B, cout, int foo A, B, and line. Let's add in here a space, because I don't remember C++ will add spaces like that, so to be safe. Okay, and let's put that there just again so we can see it all on the same page. Okay, so run the code, it still runs the same. In fact, I copied and pasted the line, so we see two double foos. We never see this called, but now if we take this and we pass in 2.5, we run the code again, we can see that the first two use the first one, int foo. The third one, the 22.5, uses the double foo. And then the last one uses this new foo that we just made, int foo. Okay? And they all have the same function name foo. Why is this cool? Again, flexibility of code. Let's say you create a really awesome multiplication function that can multiply two numbers. You want it to take any kind of number, then you make one that takes doubles, one that takes floats, one that takes integers, one that takes your special type of integer that you create in the future when we talk about classes. You can do that. It's very powerful. It allows flexibility, and it is a form of, I suppose, polymorphism, which is a very fancy word that basically means multiple shapes. And in this case, it's called, it's compile time polymorphism. Let me write that word so that you can see how it's spelled and everything. Because at least for me, it's like too long of a word to remember of. Compile time polymorphism. Poly is many, and I believe morph is shapes or faces, one of the two. It's like Latin or Greek, one of those things. Okay? So that's what polymorphism is. And you'll hear this word throughout the semester applied to different things that I teach you. Okay? So this is a compile time. There are also runtime polymorphism. That's like what I would say is real polymorphism. But, you know, things like template and, which you haven't heard about, don't worry, but we will talk about them. Things like templates and this is compile time polymorphism. Okay? So, again, this is very powerful because you can make a print function that can do a lot of things. That's how printf works in C, you know, with this polymorphism idea. And it's great until you run into problems. So what kind of problems can you run into? Okay, let us try and break this. So instead of a 10 here, let's start passing a float. Let's see where our float goes to. So now, here's a situation that we don't know what's going to happen. So with a float is not an integer and it's not a double. So what the compiler tries to do when you're compiling code that's using these kind of function overloading. And by the way, I hope you get the reason why it's called overloading, right? Function overloading, because you're like overloading what it can do kind of thing. You know, you're upgrading it. So yeah, but anyways, so the first and most obvious thing that happens with the when you're overloading a function and it's trying to resolve which function to call, is that it's going to look at the parameters of the call, of the function call. So I have foo, and then I have some parameter here and some parameter there. And I'm just using random shapes, although I don't like this one because it's a symbol for infinity. So let's just say that. So we have two symbols, okay? So what it's trying to do is it's identifying the type of the symbols. So it's like, okay, this is orange type and this is red type. And then it's going to look at a table of the functions that you declare in the code. So it's going to have foo in here, 3 of them. And maybe this one takes red. This one takes orange or yellow, whatever that is. Then there's one that takes pink. Who knows which one that is? We haven't talked about yet. But like, let's just say there's one that does that. And then there's one that takes orange and red. Okay? So basically, it tries to match it. So it's like, well, the first and most obvious thing that first does is it counts how many parameters there are. So here it's like, well, there's 2 of them. And these are all 1, 1, 2. So off the bat, it's like, well, it's not going to be that, it's not going to be that, and it's not going to be that. And this could be it, maybe. Okay? Let's add one more example here, actually. Maybe there's another foo in here that takes this and this. Okay? So this takes 2. So technically speaking, this could be a possibility as well. Okay? So that's the first check that it does. But now it needs to check the variable types. So then it's like, well, we have an orange and we have a red. If it's looking at the red, it can see that both of these are okay for the red. So that's okay. But for the orange, it's like, well, that one doesn't work because it's purple. So it has to be that one. In this case, when it has an exact match, it's the best case scenario because like then there's no ambiguity. Let me give you a scenario where things are not this nice. Suppose that instead of this being here, maybe this is 2 reds. Or maybe this is a totally different color. So this process is the same. It looks at the number of parameters and it's like, okay, well, it cannot be any of the first 3 because it needs to always have the exact same number of parameters. Otherwise you get an error. Where things get iffy is like, okay, you have 2 of them that have the same number of parameters. So that's a good start. There's no error there so far. But now it has to pick. And it's like, well, okay, again, the second parameter is red, so you could be either one of these. But then it sees the first parameter and it's orange. And it's like, oh, snap. I have a purple and I have a red. Who do I pick as a compiler? Which one is he referring to? Like, were they crazy when they're trying to figure out like which one do they want? So the compiler at this point is going to try to help you out. And it's going to try to look at similarities between the type that you give and the types available. It will do things like casting. So it might cast like a double to a float, maybe. I'm not 100% sure. We'll test it in a second. Or it might cast like a double to an integer. So like in this case, if these are both integers, and this is like a string, then if you're feeding it this, which happens to be a double, so now I'm giving color, so the orange was actually doubles, the int was reds, and the purple was string. If that's the case, then it's going to be like, okay, well, a string is like text, whereas like a double is at least a number. So like I can cast this double to an integer, and yes, there's going to be loss of precision, but like at least it'll work. Whereas with the string, it just flat out does not work. It can't convert a number to a string without a function to do that, like to int or something, s2i. So here's that in case you ever want to use it. S2i will convert a string to an integer. So yeah, if I went ahead and passed that in there, if I have a string and I put that in there, then that'd be okay. But yeah, so that's what it will try to do. And that's where things get ambiguous because it's something not so obvious what it's trying to do. So first of all, to avoid that situation, have a function for any possible case. Like overload it with even more functions that have all possible cases. Or if not, at least test it to make sure that it's going to the right function or that the code even compiles. When it's totally lost, when it's like, well, I don't know what to do, it would just not compile and it'll give you an error. So let us try to actually see these errors in practice. So let's go ahead and make another function. And we're going to call this one double A and int B. And this one will be cout double int foo A the space B. By the way, these don't have to have the same body, but I'm just trying to be consistent. They could be totally different functions once you actually do them. Although, why would you? You just name it something else, right? Okay, so right now we are calling to 5. So let us go ahead and call something that might be ambiguous. So let's feed it a number first. But for the second thing, well, here, let's just flat out feed it a string, so it gets confused. Or actually, yeah, let's feed it a string. Okay? Let's look at what we get. Show errors. So we get no instance of overloaded function foo matches the argument types. Invalid conversion from constant char to int. So first of all, it's like, I can't even convert your string to an int. And second of all, there isn't a string function that can accept it. So one or the other doesn't work, so no go. Okay? So yeah, that's the end of that, basically, okay? However, let us go ahead and pass in here a float. .12. Okay. In this case, it compiled and it ran. Okay, let's look at how this all went. So the initial foo here was with a float, which it said, okay, we don't have a float version of this, but at least we have a double, which is better than integer because, like, okay, double to float is a loss of precision because, like, doubles can keep, let's just simplify it and say twice as much precision as a float, which is not the case. It's you'll learn about it in 218 or 219, but it can it can keep way more accuracy because it's a bigger space, like to store these numbers at. Okay, the way it works. The float is smaller, but it can still keep like precision. So you will lose precision, but it won't be like flat out completely lost as if you went from a decimal value to like just an integer. That's like massive loss of precision. That's like 2.9 going down to 2 is like massive loss versus like 2.985 going down to like 2.984 just because of how the way floats work. Totally, completely different levels. They're both bad. Like, you shouldn't be doing this. Like, you should never have a situation where this happens, where you go from double to float, because it's bad and dangerous, because you don't have control over that position loss. But hey, the compiler, you know, gave you a hand and let you compile it, okay? It said, sure, okay, alien versus predator, lesser of two evils kind of thing. The float is the lesser of two evils. So it goes for that. With the integer, that's no problem. It's an exact match to the integer, so it's like, okay, we're good to go with that. With the double, it's like, cool, we have a double and we have a double. So there's no, again, it's an exact match, no problem. When we get to our weird situation, where we have a float and an int. It could have gone either way, but it took the same decision as it did it with the first example. It's like, okay, there isn't an exact match, but between the int and the double is the better choice. So whereas with the string, it's just like, I have no idea what you want to do. With the float, it's like, well, I guess the double. Actually, you know, since we're going from float to double, and not, if we were going from double to float, there would be loss of precision. Going from float to double, I don't know if there would be, because the double can keep a more accurate value. But the way that it's set up, it's possible that the same set of numbers may not fit in one than the other. So there might be, but I don't think so. I don't want to give you a resounding answer because I'm not sure. But it's still bad. You shouldn't be swapping things between floats and doubles. Like, no. Stick to one type, okay? Yeah. Let's try something else, like a car. Literally car. Let's see what happens with this one. With this one, the car is an ASCII value. It's an integer. Well, close to an integer. So technically speaking, it's better off going with the integer wrap than going with the double wrap. So it went that way. Okay? So let's do one more that might be ambiguous. Let's play advocate and make this into a, let's make it into a double. Let's make a float. So in this case, it is going with, interesting, it went with the integer. Why did it go with that one? Well, because this is closest to an integer. And then, you know, between these two, this one's a double, so that already kind of gives it away. Okay, that's not as exciting. Let's do one where, let's do two doubles. Yeah, that one's gonna be good, I think. Let's do 22.5 and 23.5. And before we run it, let's think about what's gonna happen in this one. So obviously this will match with the double here, but this will not match, right? With neither of these. So it should go with this one, actually. Actually, that's not as interesting, but oh well. Let's run it. Yeah, so it went with double int. Let's add another case here that makes things more interesting. Yeah. Let's add a case where this is an integer and this is a double. Okay? So now this is basically int double. Like that. Okay? So now, let's make sure it runs still. Okay, it runs still. Let's try to run this one now. Okay? This one, oh, it already doesn't like it. That's cool. It's not going to like it because there's two doubles. So this one flat out just doesn't work because it's two integers. So both arguments, both parameters are not what you want. This one, the first parameter is good, so it likes that one. But the second one is not, so it's off by one. And in the past, before we added this, it was going automatically for that one. Like, if I comment this out, it goes for this one, the double int foo. However, now that I've added this one, the exact same code, it's going to have a hard time trying to decide. It can't decide. It's ambiguous. I don't like that this doesn't give me the error the compiler would give me. Here, let me run this in the compiler so you can see the error, like, in the compiler. G++, is it main? Main. There we go. So this is the error you get in the compiler. Main function blah 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 overloaded foo double double is ambiguous, and it tells you the candidates that it's trying to pick between. It's like, well, you have an int, you have a double int, and you have an int double, but like I don't know which one you're trying to do, because the first one is just like both of them are different. The second one, like you have a double and an int, so like one of them works, but the other one would have to like lose precision. The third one, the second parameter works, but the first one loses precision. So basically, both of these are the same distance away from when you start with. So when you only have one of them, it's cool because it's like, well, you got, I guess that's the only choice. But since you're giving it more options, this is when it's like, oh, well, technically both of these are like candidates. So I can't make a decision for you. And it's good that it gives you that error. You don't want it to like just like be like, well, let's toss a coin and go with one of them. No, that would be very bad. Yeah, you want this to be an error. You don't want this to be to slip by. Okay? Sometimes compiler errors are useful, so make sure you read them when you get them. So yeah, I like that more than this one. This one doesn't really kind of list out the error as nice. Okay? That's what function overloading is, and in a short version of that. It's the ability to have multiple functions with the same name that can do multiple things or the same thing in different ways. And the variation is that you have different number of parameters. And so that allows you to have flexibility. And again, this is all to achieve that compile time polymorphism, which is cool. Again, could you code your entire life without using a single function overloaded? Absolutely. Would you want to do that? No, because a lot of the times when you do a print function, like you overload it so that like it's clean. You just call print and it prints no matter what you feed it. You don't have to worry about that. You know that if you call print, it'll print. It'll work like a champ. Okay? So that's function overloading. I've also shown you the dangers of it and how to avoid those dangers. You have to be very precise with your parameters and consider all instances. If you know what unit testing is, this is an example that would be ideal for something you would want to unit test. If you don't know what that is, don't worry about it. Someday they'll talk about it in some of your classes. Maybe like the last class you take. It's the idea of like testing all edge cases of your code to make it more robust. Okay? So, do we have any questions or any comments? Anything? How you feel about that? You feel strong with function overloading now? Like, yeah. Does auto work for parameter type? No, I don't think it does, because it needs to know what type of parameter you're passing, so it will complain probably. If you want to do something like what an auto would do, that's what templates are. Basically, templates allow you to have that auto power where the type is defined based on the function call. So you will get to see that like week 12 when we talk about templates. So that will be basically the same thing because in your mind you're thinking like, can I just make the parameter be auto A? And like, that functionality is amazing because like you could just make it work for any parameter, right? And that's literally what templates will do. So yes, that exists, but it's not with auto. It's using a template, and we will cover in this class. You said you will post a link for the debug video on Canvas. Yep, I will. I can also post it now if you want. So I've created a playlist for this class, and all videos that I upload will be there. So save it. Save the link for that. That will be your 202 playlist. All lecture videos will be uploaded there. So if you subscribe to my channel, you'll get notifications when they get uploaded. But you'll also get notifications when the 302 videos get uploaded. So just be aware of that. But I label them, so you'll know. Okay? The TA office hours are posted on Canvas and also on Discord. So I do think she said that, Monday, Wednesday, 11:30 to 12:30. But even if she decides to change them, or if you ever need them, you can find them there. So, that way you don't have to like remember them. So, yep. I made a video talking about the assignment that's like 24 minutes long. You can watch. But other than that, there isn't much that I can say that can help you unless you have a particular question that like you're like, okay, this is exactly what I'm stuck with. My recommendation to you with the assignment is to get the parsing down first, to be able to read the text, which you may want to use like a string function to handle that issue. And use your vector instead of using an array if you can to avoid potential crashes. But yeah, I mean, what I said in the video stands. It's not particularly a hard assignment. It's just, it takes a little bit of thought of how you approach the problem. Do you want us to write function definitions about the main? Dolly had us write those. The TA is the one that grades it, so you want to talk to her and see what she's looking for. But also you can look at my syllabus. So I do have that as part of the thing, that I want you to put your function definition like comment above it. But since ultimately the TA is the one that's kind of looking at that, then you can ask her, because she might be like, nah, that's fine, But at least that's what I gave her, and then she can modify that as she wills, but she will follow it probably. So yeah, make sure you write your class and function definitions when you learn classes, and document your code, make it look pretty, and basically it's like make something that you're proud of, kind of thing. Okay, I'm going to stop the recording, and then I'll hang out for maybe 5 more minutes if you have any more questions, and then I guess I can open the Twitch poll to see what happens with that. But let me stop the recording at least on YouTube, since YouTube people don't need to see anything else, I guess. But yeah, okay. For those of you on YouTube, then I'll see you next time.